Okay, so for this problem, we're going to find the distance and the travel time. So our assumptions are that our initial velocity is 6 meters per second, and it was kicked at 55 degrees. So I have a little chart here for the x and y components, which are seen here. For x, acceleration is always 0 meters per second squared because it's constant the whole way. While for y, it's negative 9.81 meters per second squared because of gravity. For the initial velocities, we're going to need to use what we have here. So we take 6 cosine of 55 for the x component and 6 sine of 55 for the y. And so for x, we get 3.44 meters per second. And for y, we get 4.914 meters per second. What we need to find is this, the change in the x direction, displacement, and then time. We already have y displacement at 0 because we're starting down here, going up and coming back down. And we end at the same place we started, making the displacement 0 meters. So, first thing we need to find is time. To do that, we use the equation change in y equals initial velocity times time plus 1/2 acceleration t squared. So we fill in here what we know. 0 equals 4.914 times time plus negative 9.81 times 1/2 is negative 4.905 t squared. And here, since it's equal to 0, we can take out the greatest common factor, which is t. And so that gives us 4.914 plus negative 4.905 t. So that we can just cross that out because it equals 0. And so now we have negative 4.905 t. You can subtract that over, get negative 4.914. Divide that and we get t equals 1.002 seconds. Now that we have t, we can find the change in x. So to do that, we use the equation change in x equals initial velocity times time plus 1/2 a t squared. So because a equals 0, this whole part equals 0, we can just cross it out. So we're finding change in x. Initial velocity is 3.44 times 1.002. And we multiply those together, and we get change in x equals 3.446 meters. So there we go. There's our change in x displacement and our travel time.